So now we see the problems based on the equal h nu, that is Max Planck's equation, that is equal h q. So now we see some problems based on that formula. So see the first problem. So compare the energies of two radiations. One is with wavelength of 300 nanometer and another is with 600 nanometers. Here simply it is asked that comparing their energies. Just comparing their energies. So we know here two wavelengths are given. We need to compare this their energies. So we know the general equation equal h nu. In the place of nu we can write c by lambda. And we know the relation between E and E, that is inversely proportional. So we can write here, already in the formula we see that E1 by E2 is equal, that is lambda 2 by lambda 1. So now the energies are, the E1 by E2 is equal to, the lambda E2 is 600 nanometer. So here we are just comparing, therefore there is no need to change their units, both are in same units. Generally we never do the problems in nanometers in general calculations, but here we are just comparing two energies. Their units will be cancelled in the ratio, therefore we are not converting the units. Generally మనం A equal h c by lambda equal h nu problems లో లాంబ్డా వాల్యూ ఎప్పుడు నానోమీటర్స్లో కానీ యాంగ్స్ట్రమ్స్లో కానీ తీసుకోం, ఎప్పుడైనా మీటర్స్ కానీ సెంటీమీటర్స్ కానీ తీసుకోవాలి. బట్ ఈ ప్రాబ్లంలో మనం ఓన్లీ కంపేర్ చేస్తున్నాం. కంపేర్ చేస్తున్నప్పుడు మనం రేషియో తీసుకుంటున్నామంటే యూనిట్స్ విల్ బి క్యాన్సల్డ్, జస్ట్ ఫర్ వీఆర్ నాట్ ఎట్ ఆల్ చేంజింగ్ ద యూనిట్స్. సెకండ్ బై 300. So they are in the ratio of 2:1, that is E1 equals 2 into E2. Okay, let's take it. So the next one, calculate the energy of 1 mole of photons of radiation having frequency 5 into 10 power 14 hertz. So here frequency is given, we need to find the energy of 1 mole of photons. We know photon means the light is consists of particles. The light particles are known as photons. The energy particles of light are called photons. Here already we know the Max Planck's equation equal h nu. Just remember that this equation is always used for one photon. This is applicable only for one particle. Means for this problem we can say the energy of one photon is the energy of one photon is, that is E is equal h nu. The frequency is given, h value we know it's a Planck's constant 6.625 into minus 34 joule into second. New value 10 power 14. Yes, 6.6255, it is approximately 33.125 into 10 power 34 is minus 20 joules. It is joule into second, hertz means second inverse. This is joule into second, hertz means second inverse. It becomes joules. Means the energy of one photon is this much. We need to calculate energy of 1 mole of photons. So energy of one photon equal 33.125 into 10 power minus 20 joules. So what about energy of 6.023 into 10 power 23 photons equal how much? So we know that since 1 mole equals always 6.023 into 10 power 23. The general in the calculation purpose we can take 6 also, there is no problem in it. But here exactly we are taking 6.023 into 10 power 23. With the help of E equal h nu always we are able to calculate energy of one photon only. Energy of one photon you got 33.125 into 10 power minus 20 joules, because we took the Planck's constant in joule into second, so we got the energy in joules. So one photon has this much of energy. What about 1 mole? 1 mole number is always 6.023 into 10 power 23 photon is having how much energy? So that is approximately 6 pound, this is 10 power 23, 20 means 10 power 3. This total in terms of joules, 6, it is equal to approximately 199.5 into 10 power 3 joules. Into 10 power 3 joules place, we can write 199.5 kilojoules. So it is the energy of 1 mole of photons in kilojoules. This is in normal joules. Okay. Here we need to remember the 1 mole is this much. It is energy of only one particle always. One particle you got this much of energy. We calculate it for 1 mole. 1 mole number we know that. Okay, just take it. Okay, see the third one. A 100-watt bulb. Here the voltage is given as 100 watt. Bulb emits a monochromatic light. A monochromatic light means generally light obtained from the normal bulb. Here bulb emits generally in just very few years ago we used just bulbs in the place of tubes and in the place of LEDs. Okay. So the released light of that type of bulbs is called monochromatic light of wavelength 400 nanometers. So the light emitted by it wavelength 400 nanometers. The bulb capacity is 100 watts. We need to calculate the number of photons that emitted per second by the bulb. When here bulb means releasing energy, releasing light means light is consists of energy in the form of photons. We need to find how many number of photons we released from that bulb in 1 second of time. So its capacity of the bulb, the power of bulb is given. Power of bulb is 100 watts. So what it means by this power of bulb 100 watts means it releases 100 joules of energy, 100 joules of energy in 1 second. The bulb energy capacity 100 watts. It means it releases 100 joules of energy in 1 second of time. Okay, generally we never get this 100 watts, this very high watts of bulbs in LED or in normal tubes. That's why these bulbs take more consumption of light, more consumption of power. But there is not at all side effects with this monochromatic light released by this type of bulbs. But there is some side effects takes place to the eyes of children. Mainly if you use the long time for reading. Okay, LED bulbs are not perfectly suitable for reading, for long purpose. Okay, normal tubes are better for everything. Okay, see here, the 100 watts bulb releases 100 joules of energy in 1 second. So we need to find the number of photons released in it, number of photons present in this 100 joules of energy. So what is the light is having wavelength 400 nanometer. We know that energy of one photon is called h nu. Here frequency is not given in terms of lambda is given. We can write hc by lambda. So therefore here is called h value. We know the constant. We are taking in SI method minus 34 joules into second. At the time speed of light must be taken SI units, that is 10 power 8 meters per second. But what is lambda? 480 nanometers. Sorry, 400 nanometers. Nanometers means 10 to the power minus 9 meters. So on this calculation we will get is equal to 6.625 3 to the power minus 34 approximately. Write is 10 square here. Here 6 point, here we get E is equal to minus 19 by 4. And finally we get energy is equal to 4.968 into 10 to the power minus 19 joules. So what is this energy? This energy is energy of one photon. The energy of one photon is 4.968 into 10 to the power minus 19 joules, which are present in this type of light. Now we need to calculate the number of photons present in 100 joules in 1 second. Already these 100 joules are released in 1 second. Only 1 second of time is given. In 1 second of time, 100 joules of energy is released. Just simply we need to calculate the 100 joules contain how many photons. This is energy of one photon, means 4.968 into 10 to the power minus 19 joules of energy possessed by one photon. Then what about 100 joules possessed by how many photons? This is approximately equal to 1 by, if you take it's a 5 value, then take it 2 into 10 power 20 photons per second. 2 into 10 power 20 photons released in 1 second, because in 1 second there is releasing of 100 joules of energy. 100 joules of energy is released in 1 second. One photon energy is 4.96 10 4 minus 19, means 4.9668 into 10 4 minus 19 joules possessed by one photon. Then 100 joules possessed by how many photons? We will get 2 into 10 power 20 photons in 1 second. 1 second means it is given in at the starting. When there is releasing of 2 into 10 power 20 photons in 1 second of time. Okay, take it now. Okay, see the next one. So nearly similar to the earlier problem. So calculate the number of photons emitted in 10 hours by a 60 watt sodium lamp. Here sodium lamp is so another type of light. Here the capacity of the bulb is 60 watts. We need to find the number of photon in 10 hours. The lambda of the light 5893 angstroms. Here it is a fixed one for the sodium lamp. Okay, the always sodium lamp light is having two type of wavelengths, that is 5893 angstroms. The other one is 5898 angstroms. They called as D1 and D2 values for sodium lamp. Here we need to calculate the number of photons emitted in 10 hours. In earlier problem we calculated the number of photons in 1 second. So because only 60 watt means that is nothing but in 1 second. Means in the same way we calculated per second in earlier problem. Just do the same in this problem only. In this problem also. Then it is converted into 10 hours. First with the help of 60 watts information we can calculate for 1 second only, because the bulb power is nothing but the power of bulb is 60 watt. 60 watt means it releases 60 joules of energy. It releases 60 joules of energy in 1 second. Means directly 60 joules is for calculate this thing. We will get for 1 second. Just like earlier problem. Then afterwards we calculate it for 10 hours. So 60 joules of 1 second, 60 joules of energy release అవుతుంది. అది 60 joules of energy లో ఎన్ని photons ఉంటాయి find out చేద్దాం. So what is the energy of one photon first? Energy of one photon always is equal to h nu. If frequency is given directly nu తీసుకోవచ్చు. frequency ఇస్తే ఇక్కడ is lambda కాబట్టి hc by lambda. So that is E is equal to h value 6.625 into 10 power minus 34 joule into second. See, we know that light speed 10 power 8 meters per second. ఇక్కడ మనం 6.625 10 power minus 34 joules తీసుకున్నాం SI మెథడ్ లో. కాబట్టి 3 into 10 power 8 meters per second SI మెథడ్ తీసుకోవాలి. By lambda, so 5893 angstroms. We never do the calculation in terms of angstroms and nanometer. Centimeters లో కానీ meters లో కానీ తీసుకోవాలి. SI మెథడ్ తీసుకుంటే మనం meters తీసుకోవాలి. అదే CGS మెథడ్ తీసుకుంటే సెంటీమీటర్స్. ఇక్కడ ఆల్రెడీ మనం SI మెథడ్ ఫాలో అయ్యాం కాబట్టి ఈ angstroms SI మెథడ్ లెంగ్త్ లో meters లో కన్వర్ట్ చేద్దాం. 10 meters. So here we get energy is equal to 9.75. 4 means becomes 19 point. Here approximately we get 0.00 10 power minus 16, and we change it as minimum 3.373 to 10 to the power of minus 19 joules. So this is not the answer. This is the energy of one photon. One photon की इंत energy उनके means 3.373 into 10 power minus 19 joules of energy possessed by one photon. Then what about 60 joules of energy possessed by how many photons? That is 3.373 into 10 power minus 19 joules is possessed by nothing but it haved by one photon. So 60 joules unte dantlo any photons untayi. So here we get in 1 second of time. అంటే మనం 60 watts అనేది 60 watts అనేది 1 watts means joules in second. కాబట్టి 60 joules తీసుకుందామంటే నథింగ్ బట్ 1 second తీసుకున్నాం మనం. ఇక్కడ 1 second లో 60 joules of energy రిలీజ్ అవుతుంది. ఆ 60 joules అన్ని ఫోటాన్స్ ఉంటాయి. 17.7882 to 10 power plus 19 photons ఉంటాయి. 17.788 into 10 power 19 photons released in 1 second. It is just up to the earlier problem, the same order. Here the extension is 10 hours. 10 hours ka 1 second telsu 10 hours calculate cheyali. In 1 second 17.788 to 10 power 19. In 10 hours it is equal to 10 hours, minutes to seconds. So finally we get 6.4 into 10 power 24 photons. 6.4 into 10 power 24 photons in 10 hours of time. Okay, take it. Okay, see the next one, different from earlier problems. An electromagnetic radiation of wavelength 242 nanometers. Here lambda is given at 242 nanometer. It is just sufficient to ionize a sodium atom. And the sodium atom ionization means sodium plus la convert cheyadani to make the sodium into sodium plus. That is ionization of sodium. It need light having wavelength 242 nanometer. So calculate the ionization of energy of sodium in kilojoules per mole. So what is general ionization energy? The amount of energy required to remove an electron from a gaseous isolated neutral atom. అంటే ఒక న్యూట్రల్ ఆటమ్ నుంచి 1 ఎలక్ట్రాన్ రిమూవ్ చేయడానికి the amount of energy released, the amount of energy required, the amount of energy required to remove an electron from a gaseous neutral atom is called ionization energy. So it is given for one atom, it is given, we need to calculate for 1 mole. Okay, first we convert this wavelength into energy. అంటే 1 atom of sodium ని sodium plus గా కన్వర్ట్ చేయాలంటే ఆ లైట్ సమ్ ఎనర్జీ అవసరం. అయితే ఆ ఎనర్జీ మనం ఫైండ్ అవుట్ చేయాలి. ద గివెన్ ఇన్ఫర్మేషన్ ఈస్ ఆ లైట్ కి సంబంధించిన ఎనర్జీ తెలవాలంటే మనకి ఇచ్చిన క్లూ ఏంటి, ఇక్కడ లాంబ్డా ఇచ్చింది. ఈ లాంబ్డా వాల్యూతోని we can calculate the energy. So E is equal to h nu. Nu is not given, the C by lambda, h 6.625 into 10 power 4. Speed of light meters per second. So here the lambda is given 242 nanometer. We can make it 5 3 there is this comes to so this 19.875 by 242, so approximately equal to 0.0821 into here 10 to the power of minus 17 joules, or we can write it as 8.21 into making 2 points right side minus 90 joules. So this is energy required. This is energy required to remove an electron from a gaseous neutral sodium atom. అంటే sodium atom నుంచి 1 electron remove చేయడానికి just 1 sodium atom just sufficient to ionize a sodium atom. అంటే 1 sodium atom నుంచి electron remove చేయాలంటే 8.21 into 10 for minus 19 joules of energy అవసరం. ఇది మనం ఫైండ్ అవుట్ చేయాల్సింది 1 mole of electron ఫైండ్ అవుట్ చేయాలి. To remove 1 electron need how much energy? 8.21 into 10 to the power of minus 19 joules of energy. Then 1 mole find out that. So what about to remove 6.023 into 10 to the power 20, which is equal to 1 mole electron, need how much? So a 6.02 to the power 23 electrons means they are present in not in one atom, they are present in 1 mole of sodium atoms. At 1 mole of sodium atom నుంచి ఇక్కడ 1 atom నుంచి 1 electron తీసేది. ఇక్కడ 1 mole నుంచి అన్నిట్లో నుంచి 1 తీసేసి that is 1 mole electrons. So it is equal to, so approximately it gives joules, or we can write it as joules. So for 1 mole of sodium atoms no ionize చేయాలంటే అంటే 1 mole of sodium atoms ని sodium plus గా కన్వర్ట్ చేయాలంటే to remove 1 electron from all atoms present in 1 mole of sodium is requires 494.5 into 10 power 3 joules. So it is asked in terms of kilojoules. So we can write it as kilojoules. So it requires 494.5 kilojoules to remove the 1 electron each from 1 mole of sodium atoms. Okay. Okay, see the last one. So which is also similar to the first two problems, but at the time we done the problem in a clarity, means total explanation concept based on a problem చేస్తాం మనం. సో ఇక్కడ మనం డైరెక్ట్ తో ప్రాబ్లం చేద్దాం, ఎగ్జాక్ట్లీ ఫస్ట్ ప్రాబ్లం సెకండ్ ప్రాబ్లం మోడల్లోనే, బట్ హియర్ దేర్ ఇస్ ఎ డైరెక్ట్ స్టెప్ ఈస్ దేర్. Just to understand the perfect to the problem, we done the total with the detailed explanation in first two problems. So this is also somewhat same model, but this last problem we done in a direct step, means just taking by direct formula. The calculation is same one, this formula is direct. Here just different is same. The bulb emits a light of wavelength 4500 angstroms, means its wavelength is given, and the bulb is rated as 150 watts, and ఇక్కడ bulb power is 150 watts. కానీ దీంట్లో వర్క్ చేసేది ఏంటంటే it works only 8% of the energy is emitted as light. So 150 watts అంటే జనరల్గా 150 joules of energy రిలీజ్ చేయాలి in 1 second, but it works only 8% వర్క్ చేస్తుంది. Means its efficiency is just 8% and it is not 100% pure. So we need to find the same number of photons released in 1 second. So 1 second of time lo, so how many photons will be released and find out cheyali. Same, the bulb capacity, the bulb power is 150 watts. 150 watt means nothing but 150 watts means 150 joules in 1 second, but it works only up to 8%. So 8% we will get that is 12 joules of energy in 1 second. Means the energy released from the bulb is just 12 joules from in 1 second. So actually normal problems 150 watts means simply we said that 150 joules of 150 watts means 150 joules of energy releases in 1 second. But the bulb efficiency is not good. Its efficiency is just 8%. Coming like 8% we will get 12 joules of energy. So it means that 12 joules of energy released in 1 second. Same, we need to find the number of photons. We know energy of one photon is equal h nu, and here we are calculating directly that E is equal n h nu. We are taking here n is equal to, we can take as number of photons. So nu the lambda, we need to calculate that n. The earlier first two problems also we can do with help of this formula. Here n equals A into lambda by hc. Energy 12 joules. Lambda is given how much? 4500 angstroms. Change into meters. H 6.625 minus 34 joules. C means in meters SI method to 8 meters per second. So this, and here we get that is 45 and square or minus 8. This also become minus 8. Become 10 power plus 34. and here we get 12 into 45 is 540. 3 is there. So here minus 16. Okay, minus 16, 34. 545, 19.875. So approximately here we get finally we get 2.716 into 10 power 18 photons. 18 photons in 1 second. Photons per second. Okay, here we are using directly E is called NHU. In any time, number of photons find out చేయాల్సి వచ్చినప్పుడు ప్రతిసారి E is called NHU use చేయొచ్చు. But first two problems are just they are starting problems. So what is the perfect concept understand చేసుకోవడానికి we done the total steps, that is in 2 steps. See separate గా it is equal NHU by taking n is equal to number of photons. Okay, so practice these problems and same type of and a similar model of problems will give in worksheet. So compulsory worksheet lo ఉన్న problems ఈ problems notes లో చేయాలి. సో స్కూల్స్ మళ్ళీ స్టార్ట్ చేసిన తర్వాత ఆ నోట్స్లు సార్స్ చెక్ చేస్తారు కాబట్టి సో కంపల్సరీగా ఈ ఇక్కడ చెప్పిన ప్రాబ్లమ్స్ వర్క్షీట్లో ఇచ్చిన ప్రాబ్లమ్స్ ఒకే చోట ఉండాలి. మెయిన్ అది బట్ టాపిక్ వైజ్గా ఉండాలి. సో హియర్ ఇంపార్టెంట్ పాయింట్ ఈజ్ సో ఈ ప్రాబ్లం చేసేటప్పుడు ఈజ్ ఈక్వల్ టు హెచ్ న్యూ యూజ్ చేస్తాం మనం. సో ఈజ్ ఈక్వల్ హెచ్ న్యూ యూజ్ చేసినప్పుడు హెచ్ వాల్యూ టేకింగ్ ఆఫ్ హెచ్ వాల్యూ ఇన్ స్పెసిఫిక్ యూనిట్స్ ఈజ్ ఇంపార్టెంట్. ఇఫ్ యూ ఫాలో ద ఎస్ఐ యూనిట్స్ అంటే హెచ్ వాల్యూను జౌల్స్లో తీసుకున్నాం అంటే 6.625 ఇంటూ 10⁻34 జౌల్ ఇంటూ సెకండ్ తీసుకుంటే ఇదే ఫార్ములాలో ఇఫ్ యూజ్ మాస్ దట్ ఈస్ మస్ట్ బీ ఇన్ కేజెస్, length must be in meters, energy in joules, speed in meters per second, nothing but velocity, the time will be nothing but in seconds. If you use the CGS method and H value మనకి CGS method లో erg into second 6.625 into 10⁻27 erg into second. So that is అంటే ఎప్పుడైనా మనం CGS మెథడ్ యూజ్ చేస్తే ఏదైనా ప్రాబ్లంలో ఈ లింక్స్ వస్తాయి. కంపల్సరీ మాస్ గ్రామ్లో ఉంటే లెంగ్త్ మస్ట్ బీ ఇన్ సెంటీమీటర్, ఎనర్జీ అప్పుడు అదే టైంలో ఎర్గ్లో ఉంటుంది, స్పీడ్ దట్ బట్ వెలాసిటీ హియర్ సెంటీమీటర్ పర్ సెకండ్, ద టైమ్ నార్మల్ సెకండ్, దర్ ఇస్ నో చేంజ్ ఇన్ టైమ్. ఓకే, సో ఈ ప్రాబ్లం చూసేటప్పుడు వి మస్ట్ రిమెంబర్ దీస్ యూనిట్స్ చేంజ్ వచ్చిన విల్ చేంజ్ ఇన్ ద ఆన్సర్. ఓకే.